Top extreme oversized load transportations at another level. Moving an ordinary load is one thing, but when the cargo dwarfs buildings, spans multiple trailers, or needs an entire route re-engineered, it enters the world of extremely oversized transport. From aircraft moving through city streets to 10,000-ton oil rigs crawling across continents, here are some awe-inspiring examples of transport taken to an entirely new level. Number 1. Aircraft through urban maze, France. In the quiet town of Nort-sur-Erdre, near Nantes, a truly jaw-dropping logistical operation took center stage, one that looked more like a scene from a movie than real life. The cargo? A Shajhat Tonas Transal C Shajhat Van military transport aircraft. The challenge? Navigating this colossal airframe through a medieval-style urban maze filled with narrow roads, low-hanging power lines, sharp corners, and ancient stone buildings barely a meter apart. Transport Glier, a company renowned for its engineering precision, led the effort with unmatched expertise. The aircraft, stripped of wings and other removable parts but still immense, was loaded onto a modular hydraulic trailer system capable of micro-adjustments to counter uneven surfaces, sudden grade changes, and tight clearances. The route itself was a puzzle. Every turn was pre-mapped using 3D scanning and drone reconnaissance. Trees were temporarily trimmed, street furniture disassembled, and traffic lights removed. A team of spotters walked alongside the load, communicating constantly with the driver, ensuring every inch was calculated. Some corners required the trailer's multi-axle system to crab walk the fuselage sideways in confined spaces. Overhead clearance was another critical issue. At several points, utility lines had to be temporarily disconnected or lifted with long poles. And in one tense moment, the aircraft passed under a bridge with only 4 centimeters to spare. Despite these challenges, the transport was executed flawlessly, turning an urban environment into a temporary runway of sorts. Number 2. Black Forest Timber Truck, Germany. Deep within the dense, misty heart of the Black Forest, where ancient pines soar hundreds of feet into the air and trails snake through steep valleys, timber hauling is not for the faint of heart. Here, the Scania 5th 8 truck, operated by Renscher Holz Transport, proves itself as more than a machine. It's a lifeline for the forestry industry and a marvel of heavy haul engineering. Designed to dominate terrain where roads often blur into trails, the 5th 8 is equipped with an ultra-powerful 16.4-liter V8 engine producing over 770 horsepower and close to 3,700 Newton-meters of torque. This kind of raw force allows the truck to pull 60-plus tons of timber up 30% gradients through soft, muddy forest tracks and along switchbacks that challenge even unladen vehicles. But power is only half the story. The truck's high ground clearance, intelligent traction control, and heavy-duty all-wheel drive system ensure it can handle snow, ice, and loose soil without slipping. A specialized forestry trailer with hydraulic bolsters enables it to adapt to irregular log lengths and shifting loads, reducing strain on the frame during transport. Inside the cab, however, it's a different world. Noise-dampening insulation, adaptive seating, and a digital control system provide the driver with comfort and real-time analytics on traction, tilt angles, and load weight distribution. In the Black Forest, weather conditions change in an instant, so predictive mapping tools and GPS-integrated terrain modeling are essential parts of the journey. Driving this route isn't just about moving cargo, it's about taming a landscape that has challenged man and machine for centuries. Each trip requires an acute understanding of the forest itself, the angles of the trail, the moisture in the soil, and the exact moment to throttle up or down. That's where Renscher Holz drivers shine, combining instinct, skill, and cutting-edge technology to ensure every log reaches the mill safely. This isn't just transport, it's an ongoing battle against nature, with the Scania 5th 8 standing proud as the ultimate weapon. Number 3. The Airbus A380 wing transport, UK to France. When building the world's largest passenger aircraft, the Airbus A380, every component is massive, but the wings are something else entirely. At over 36 meters, 118 feet long, and weighing around 40 tons each, they defy conventional logistics. Transporting them from the Broughton manufacturing facility in the UK to Airbus's final assembly line in Toulouse, France, is a logistical ballet known simply as the itinéraire à grand gabarit. This journey is a masterclass in multimodal transport coordination. First, the wings are carefully loaded onto specially designed cradles and placed on custom-built flatbed trucks with over 20 axles, which spread the immense load across road surfaces to prevent damage. These convoys are among the most complex on European roads, requiring precision turning radius calculations and specialized steering systems. Police escorts guide the convoy through rural UK roads under the cover of night, with temporary traffic signs and signal lights removed in advance. Upon reaching the coast, the wings are transferred via crane to a roll-on, roll-off barge, designed with stabilizers to handle the delicate, overhanging wings without exposing them to unnecessary stress from swells or shifts in water level. Once in France, the journey resumes on land. The convoy passes through small towns where entire roadways are modified, traffic islands flattened, power lines raised, trees trimmed, just to accommodate the wing's colossal sweep. Villages on the route often prepare for weeks in advance, with roads closed and curious residents lining up to watch the silent procession. This highly choreographed journey, taking several days to complete, is repeated dozens of times over an A380's production life. It's not just a transport operation, it's a mobile engineering marvel, demonstrating the staggering complexity behind the creation of a global aviation giant. Number 4, giant mining dump truck delivery, Australia. In the sun-scorched expanse of the Australian outback, where distances stretch for hundreds of kilometers and roads turn to dirt without warning, mining operations rely on machines of almost mythical proportions. Among them are ultra-class mining dump trucks, behemoths that, fully assembled, weigh more than 500 tons and stand taller than a 2-story building. But there's one big problem: they can't be moved whole. These trucks must be disassembled at the manufacturer's plant and shipped in segments, each a massive load in its own right. The operation begins at port cities like Perth or Darwin, where parts arrive via ocean freighter. Each component, chassis, cab, wheel hubs, tires, and hydraulic systems, is loaded onto its oversized trailer. The main frame alone often weighs over 120 tons and spans the entire width of a 2-lane highway. Transporting these loads inland to remote mines like those in the Pilbara or Northern Territory involves traversing thousands of kilometers through harsh, isolated environments. Convoys travel at reduced speeds, escorted by pilot vehicles and often accompanied by police due to the oversized nature of the loads. Roads may be closed in both directions, bridges reinforced, and communication with local authorities is constant. In particularly rugged terrain, specialized trailers with multi-axle configurations and self-leveling systems are used to manage weight shifts. Once on site, the real work begins. Assembly in the outback is no small feat. It's a round-the-clock effort under extreme temperatures, often exceeding 40 degrees Celsius, 104 degrees Fahrenheit. Crews of engineers and mechanics work with cranes, scaffolding, and precision tools to piece together the juggernaut. The tires alone, some 13 feet in diameter and weighing over 5 tons each, require specialized lifts and mounting equipment. The entire process, from port to fully assembled machine, can take several weeks. But when it's done, the reward is a machine capable of moving 400+ tons of ore in a single trip. These dump trucks are the beating heart of mining operations, and their delivery is a logistical feat that brings together global supply chains, extreme engineering, and rugged perseverance. Number 5, wind turbine blades through mountain roads, Norway. Transporting a 70-meter, 230-foot wind turbine blade is challenging under the best conditions. Now picture doing it through the steep, narrow, and icy roads of Norway's fjord-laced mountains, where sheer cliff drops flank one side and towering rock faces the other. In this breathtaking yet perilous setting, every delivery becomes a white-knuckle test of nerves, precision, and innovation. These modern wind turbine blades are longer than the wingspan of a Boeing 747 and are made from ultralight yet fragile composite materials. A single miscalculation during transport can result in catastrophic damage, costing millions. To carry them safely, Logistics companies use extendable hydraulic trailers, capable of stretching over 60 meters in length and bending at multiple joints to navigate tight switchbacks. These trailers feature active steering systems, some controlled remotely, where each axle can be turned independently to snake the load through impossibly tight corners. It's a ballet of machinery as much as a haul. In winter, conditions worsen. Snow, ice, and wind make traction difficult and visibility poor. Each blade convoy is trailed and led by escort vehicles, snow plows, and sometimes even police units. Drivers often need to reverse or adjust blade angles at inch-by-inch precision, especially when clearing cliffside bends with zero margin for error. In certain mountain passes, temporary platforms are constructed to allow the trailers to pivot or rest. Engineers also pre-survey every route using drone imagery, GPS topography models, and computer simulations to anticipate blade swing paths and ground clearance. Because many turbines are installed in remote, high-altitude wind farms, the final few kilometers often involve unpaved roads carved into mountainsides. At times, construction crews are dispatched ahead of the load to rebuild roads, shore up bridges, or carve turning areas into the terrain. Despite the overwhelming challenge, the result is a triumph of green energy logistics. Each blade, once delivered and installed, helps generate clean, renewable power for thousands of homes. But before it spins in the wind, it must first survive one of the most dramatic transport journeys on Earth. Number 6. Space Shuttle Endeavour, California, USA. When NASA retired the Space Shuttle Endeavour, its final journey wasn't into orbit. It was a 12-mile overland crawl through the streets of Los Angeles. Weighing 165,000 pounds and boasting a 78-foot wingspan, the shuttle's trip from Los Angeles International Airport, LAX, to the California Science Center was one of the most extraordinary urban transports ever executed. Unlike typical heavy hauls that move in remote areas or at night, Endeavour's route went straight through neighborhoods, across major boulevards, and beneath hundreds of trees and power lines. Preparations took over a year. Nearly 400 trees were removed with a commitment to replant 2 for each one lost. Traffic lights, street lights, and utility poles were temporarily dismantled and reinstalled along the way. The shuttle was mounted on a NASA-designed overland transporter, a multi-wheeled computer-controlled rig capable of inch-perfect adjustments to avoid obstacles. At times, the team used jack and slide techniques to pivot the orbiter sideways around tight corners. One of the most surreal moments occurred when Endeavour passed through Crenshaw Boulevard, flanked by crowds cheering just feet away. The shuttle moved at a walking pace, its wings sometimes mere inches from storefronts. Locals climbed rooftops to witness the spectacle, an icon of human achievement rolling past taco stands and gas stations. Over 2 days, the transport captivated the city and the world. But it wasn't just about moving a spacecraft. It was about orchestrating a logistical love letter to a marvel of engineering, bringing it home one last time, street by street. Number 7. Offshore oil rig modules, South Korea. Transporting modules for offshore oil platforms is a feat of engineering as massive as the rigs themselves. In South Korea, fabrication yards along the coast build gigantic modules, some weighing over 20,000 tons, to be shipped to offshore drilling locations in places like the North Sea or the Gulf of Mexico. These modules include entire living quarters, power generation units, and refinery towers, each the size of a multi-story building. Moving them from land to sea requires giant, self-propelled modular transporters, SPMTs, operating in synchronized precision, hundreds of wheels controlled by a single joystick. Once rolled onto semi-submersible heavy-lift ships, the process becomes a game of timing and tidal dynamics. The vessel ballasts itself by flooding internal tanks to sink below the waterline. The module is then floated into position before the ship resurfaces, lifting the load entirely out of the water, like a colossus rising from the sea. But that's only the beginning. The ocean journey can span thousands of miles, during which the cargo must endure violent swells, wind, and salt spray. Engineers employ wave damping systems, route forecasting, and stability calculations to prevent structural stress or shifting during transport. Once at the destination, a reverse ballet unfolds as the ship submerges, and the module is carefully floated to its installation site. There, massive cranes or jack-up vessels place it with pinpoint precision onto waiting substructures. This kind of transport operates at the edge of maritime and civil engineering, where every variable, wind, tide, load center, ballast, current, is a life or death calculation. It's not just a delivery, it's orchestrating the assembly of floating cities, piece by massive piece. Number 8. Nuclear reactor vessel transport, Czech Republic. When transporting a nuclear reactor pressure vessel, there is zero room for error. In the Czech Republic, one such vessel, measuring 13 meters long, weighing over 320 tons, and built to house radioactive materials under extreme pressure, was transported to a nuclear power plant under unprecedented scrutiny. The entire operation was planned down to the millimeter. The reactor vessel, encased in protective steel and insulation, was first loaded onto a custom-built hydraulic trailer with 24 axles, designed to evenly distribute weight and absorb road vibrations. Even the slightest stress crack during transport could render the component unusable. The convoy moved at walking speed, accompanied by military and police escorts, radiation safety officers, engineers, and civil authorities. Along the route, bridges were reinforced, temporary bypasses constructed, and high-voltage lines shut off for clearance. Every road curve and gradient had been modeled in a simulation environment months before. A critical phase involved crossing the Vltava River, where a specially engineered barge was used to float the load across. Number 9. Modular skyscraper sections, China. In China's rapidly expanding urban landscapes, speed is everything, and that includes building vertically. Enter modular skyscrapers, where entire prefabricated floors, complete with internal plumbing, wiring, and walls, are assembled off-site and then transported across bustling cities to be stacked into high-rises like oversized Lego blocks. One such project involved moving 30-ton modular apartment units, each measuring 15 meters long and 4 meters tall, through the tight city arteries of Changsha, destined for a 57-story building assembled in record time. The move took place during off-peak hours to minimize disruption, but even then, it required an urban transport symphony. Extendable flatbed trailers with GPS-linked self-steering axles navigated turns with less than 50 centimeters of clearance. Overhead utility lines were lifted manually, traffic signals rotated out of the way, and intersections temporarily redesigned to allow for wide swinging loads. Because each module was pre-finished, the risk of cosmetic or structural damage was high. Every turn, bump, and braking action was accounted for. Some modules required support cradles with shock dampening systems that absorbed road-induced vibrations to preserve interior finishes. Once on site, high-capacity cranes hoisted the modules into place within minutes. Pre-installed connection ports allowed workers to lock and seal entire apartments together like plug-and-play components. This method of modular high-rise construction isn't just a marvel of architecture, it's also a transportation achievement, requiring unprecedented synergy between manufacturing, logistics, and urban planning. 10th, mega yacht transport through Dutch canals, Netherlands. The Netherlands is famous for its intricate canal system, a network of waterways dating back centuries, winding through quaint towns and vibrant cities. But what happens when a $100 million mega yacht, crafted with cutting-edge luxury and sleek modern design, is built inland and must journey to open waters through canals barely wide enough for a rowboat? Transporting these massive, delicate yachts through the Dutch canals is a feat of patience, precision, and nerves of steel. Many of these vessels are over 70 meters long, yet some canals are only slightly wider, forcing operators to navigate with inches of clearance on either side. The journey begins at the shipyard, where yachts are floated onto specially adapted barges or pontoons equipped with hydraulic stabilizers. Navigators must account for the shifting center of gravity to prevent any tilt that could damage the vessel's delicate superstructure or expensive glasswork. Medieval stone bridges, some with clearance barely above the waterline, pose the greatest challenge. Sections of the mast or radar arrays are often temporarily dismantled or lowered, In certain cases, sections of the bridge parapets are temporarily removed and replaced after the yacht passes. Lock systems, designed centuries before the age of luxury yachts, require meticulous timing. The locks are operated manually, and water levels are adjusted with extreme care to avoid sudden jolts. Throughout the journey, crowds gather along the banks, snapping photos and marveling at the modern marvel gliding through historic waterways. Tugboats and pilot boats flank the convoy, ready to adjust the position with a gentle push if currents or wind threaten to nudge the yacht off course. This slow, elegant ballet across Dutch canals is a testament to how tradition and modern luxury intertwine. An intricate transport choreography ensuring that these floating palaces reach the sea in pristine condition. Number 11. The Goliath Power Transformer, India. India's rapidly growing energy grid requires massive power transformers, components critical to transmitting electricity over long distances. One of the heaviest and most complex to move was the transformer dubbed Goliath, weighing an eye-watering 420 tons. Transporting Goliath wasn't just about brute strength. The 64-wheel hydraulic modular trailers had to delicately distribute the transformer's immense weight over rural and sometimes poorly maintained roads in eastern India, where infrastructure was not designed for such heavy loads. The convoy averaged a mere 5 to 10 kilometers per day, inching forward with painstaking caution. Bridges along the route had to be inspected and, in many cases, reinforced or temporarily closed to traffic. A particularly daunting hurdle was the crossing of multiple rivers, some with shallow or unstable banks. Custom-built ferry pontoons were engineered to float the load across waterways that lacked permanent heavy-duty bridges. These pontoons had adjustable buoyancy systems and were connected by temporary ramps and supports. Each day's journey required on-the-fly engineering recalculations. Soil conditions, weather forecasts, and the condition of temporary reinforcements were constantly evaluated. Teams of surveyors and structural engineers traveled with the convoy, performing real-time assessments and adjusting plans as necessary. Despite the challenges, the delivery was successful, and Goliath was installed to power millions of homes. This massive transport highlighted the intersection of traditional engineering, cutting-edge technology, and the unique challenges of moving giant industrial components through developing infrastructure. 12th, train locomotive. Up a glacier, Switzerland. Moving a vintage locomotive to a mountain museum in Switzerland was no ordinary transport. It was a journey across rail, road, and cable lift systems, culminating in a climb up one of the country's iconic glaciers. The locomotive, a heavy relic of railway history, had to be preserved meticulously throughout. The first leg of the trip saw the locomotive carefully detached from existing rail lines and loaded onto specialized flatbed trailers capable of supporting the locomotive's weight while protecting its delicate mechanical components. From there, the convoy navigated twisting alpine roads, often barely wider than the trailer itself. Narrow tunnels, hairpin turns, and steep inclines demanded constant adjustments and the expertise of drivers skilled in mountain-heavy hauling. But the final and most extraordinary segment was the ascent of the glacier itself. Here, conventional transport gave way to a custom-engineered rack railway system built exclusively for this one-time move. The rack railway featured cogwheels and steel teeth to grip icy rails, allowing the locomotive to be safely pulled upward on steep, slippery slopes that no ordinary train could tackle. The operation required coordination with mountain safety teams, engineers, and historians to ensure the locomotive remained intact, both physically and historically, throughout the arduous climb. Finally, the locomotive reached its new home at the museum, poised as a centerpiece overlooking the glacier. An engineering marvel celebrated both for its past and for the remarkable journey that brought it there. 13. NASA's Saturn V rocket stage move, Huntsville, USA. Transporting the colossal SIC first stage of the Saturn V rocket, over 138 feet long and weighing 130 tons, was an event of national significance. Designed to lift Apollo astronauts beyond Earth's orbit, this historic rocket stage now needed to be moved to the U.S. Space and Rocket Center in Huntsville, Alabama, for permanent display. The transport was meticulously timed to avoid disrupting local traffic and involved nighttime-only moves across multiple interstate highways. Roads were cleared in advance with temporary removal of streetlights, signage, and overhead cables to create a clear path. To protect the rocket from vibration damage, which could jeopardize its delicate historical integrity, the stage was mounted on a platform fitted with air cushion suspension systems. The move was not just a feat of transportation, but a tribute to the space race era, one where every detail mattered, and the goal were to preserve the legacy of human space exploration for future generations to admire. Final thoughts. These feats push the boundaries of what's possible in transport. Behind each move lies a blend of engineering genius, meticulous planning, and a crew of unsung heroes solving challenges on the fly. Extreme oversized transportation isn't just about big machines. It's about precision, resilience, and the human drive to overcome the seemingly impossible. Like, subscribe and comment your thoughts below if you want more deep dives like this.